In December 2017, as Bitcoin approached $20,000, Coinbase added more new users in a week than most financial companies see in a year. Their engineering team began provisioning more infrastructure immediately. The AWS bills climbed. Requests for additional capacity went in, and then those requests started failing. Not because anything had broken, not because AWS lacked the hardware, but because the account had hit its service quotas, default limits on how much it was permitted to use at once. Revenue was surging. AWS was ready to charge for more. The quotas had not moved. The natural response to hitting a quota for the first time is disbelief. The money is there. The hardware exists. The service is running without fault. What, exactly, is the constraint? The instinct is to treat this as a billing problem, to increase spend, to upgrade the account tier, to contact the provider and ask them to unlock more capacity in exchange for higher payment. This instinct is understandable and wrong, not because the provider is being unreasonable, but because it is based on a misunderstanding of how cloud infrastructure is structured. Quotas are not a pricing mechanism, they are a resource allocation mechanism. They exist in a completely separate system from the billing system, and the two do not communicate with each other. You can have a growing bill and a full quota. You can have a small bill and vast quota headroom. The amount you spend and the amount you are permitted to use are different numbers that move independently. For a team discovering this gap at 2 a.m. during a traffic surge, it is exactly the wrong thing to find out for the first time. To understand why this separate system exists, it helps to think about how water supply works at the level of individual properties. Every building connected to a city water main has a service connection, a pipe that runs from the main into the building. The diameter of that pipe determines the maximum flow rate the property can receive. A residential connection handles the needs of a household comfortably. A hospital or large commercial kitchen needs a wider pipe, because the peak demand is higher. The water utility charges you based on what flows through that connection, how many litres pass through the meter. But billing has nothing to do with the pipe's maximum capacity. If you are running a restaurant and decide to add a second kitchen, you cannot increase your maximum water flow by paying more on your current account. You contact the utility and request a connection upgrade. They assess the local network, how much capacity remains in the main serving your street, how much headroom neighboring connections have, and then approve or deny the upgrade based on infrastructure availability, not on your willingness to pay. The pipe size and the water bill are two separate things. They do not move together. Cloud service quotas work on the same principle. Every cloud account has, for each service it can access, an allocated capacity, a pipe of a specific size. You pay based on what flows through it. The maximum flow rate is governed by a separate system entirely, and spending more does not widen the pipe. You contact the provider, request an increase, and they assess whether the shared infrastructure has the capacity to support a larger allocation for your account. The analogy has a clear limit worth naming. A physical water connection upgrade is an infrastructure project. It can take weeks. Cloud quota increases, for many services, are approved within hours through a process that happens entirely in software. The mechanism of increase is far more frictionless. But the structural reality is the same. Billing and capacity are separate systems, and one does not follow automatically from the other. Every cloud account is created with a set of default quotas, one for each service the provider offers in each region the account operates in. These defaults represent the maximum the account can consume without requesting an increase. They are calibrated to cover the needs of most accounts at most stages of growth. For the majority of customers, the majority of the time, these defaults are invisible because the account never approaches them. Quotas fall into two categories, and the distinction matters for how you plan around them. The first category is rate quotas, limits on how quickly something can happen. A maximum number of API calls per second, a ceiling on messages sent to a queue per minute. These are time-windowed. The limit resets on a rolling basis, and you can make any total volume of requests as long as you stay within the rate. The constraint is on speed, not on cumulative quantity. Stay under the rate, and the quota does not apply. The second category is resource quotas, limits on how many of something can exist simultaneously, the number of virtual machines running at once, the number of active database instances, the number of concurrent function executions. These are not time-windowed in the same way. You can run 10 virtual machines for a month without any problem. Running 11 is not permitted, regardless of how long they run or what the bill looks like. When either type of quota is reached, the cloud service does not slow down or degrade. It refuses. Requests that exceed the permitted rate or quantity are rejected immediately, and the application receives an error. The quota system does not negotiate. It does not consider payment history, account age, or the urgency of the situation. It responds to one question: is the current usage within the permitted limit? If the answer is no, the request fails. There is a defined process for changing this. Most providers offer a quota increase mechanism. You identify the specific quota, specify the new limit you are requesting, and submit a justification explaining the intended use. For the majority of quotas, this results in an increase within hours. Providers build this process in because they expect it to be used. The default is a starting point for an account, not a permanent ceiling. Some quotas cannot be raised through a request because they represent constraints in the underlying infrastructure rather than administrative policy. The number of availability zones in a region is not a quota that can be increased on request. Certain hard limits on shared services reflect actual hardware capacity, not a configuration preference. These are the limits that require architectural changes, distributing the load differently, moving to a different service type, redesigning how the system uses the resource, rather than a support ticket. A team that has been through one quota incident will often respond by requesting increases across every service preemptively. If all the limits are higher, the thinking goes, they cannot be caught by surprise again. This approach has real merit. It also has a cost worth understanding. When a provider approves a quota increase, they are making a capacity commitment, reserving infrastructure headroom against the possibility that your account will use up to the new limit. A request to increase a quota tenfold is a request for the provider to hold 10 times the capacity in reserve on your behalf. Providers approve significant increases, but they assess whether the requested capacity is likely to be used. An account requesting the maximum quota on every service on its first day will not receive those increases, not because the provider is being obstructive, but because the capacity planning system cannot distinguish between genuine anticipated growth and someone probing the ceiling for its own sake. The more practical answer is to monitor quota consumption the way you monitor everything else. Most providers expose quota usage through their monitoring APIs. The data is there. It does not appear in default dashboards because surfacing it requires a deliberate configuration decision. That decision is far easier to make before the first quota incident than after. The genuine danger of cloud quotas is not that they exist. It is that they are invisible until the moment they are hit. Billing dashboards, performance monitors, error rate graphs. None of these will surface an approaching quota limit unless someone has explicitly configured the system to track it. Quotas sit in a separate console, a separate set of numbers, entirely disconnected from the metrics most teams review daily. What Coinbase encountered in December 2017 was not a failure of their infrastructure. It was a collision with a system most engineering teams only discover when they run into it, the quota layer, which sits between a cloud account and the infrastructure it is trying to access, and which moves according to entirely different rules than the billing system does. The cloud charges you for what you use. The quota system controls what you are permitted to use. Those are two separate permissions, governed by two separate systems, and one does not grant the other. Growing on the cloud means managing both. Spending more is one kind of growth. Requesting the capacity to spend more, that is the other. Knowing that those are different problems is what changes how you plan before the ceiling appears.